Welcome to simple interest and compound interest. So let's start with simple interest. So simple interest is the formula I equals PRN. Unfortunately, this is not on your formula sheet. So you'll need to remember that I is for the simple interest earned and only the interest. Just be careful with that. P is the principal that you invest or the amount that you invest. R is the interest rate per unit of time. So we'll talk about that with a couple of examples. So time is important. And N is the number of units of times. So your rate and your N, so your number of units, need to be in the same. So the question says in days or months or years, make sure that both your rate and your N are in the same units. So let's just do two quick ones for simple interest. So we've got amount that's invested at 8%, simple interest. So it's told to us the amount that's invested is $4,500. How much will there be after 6 years? So that'll be a simple one where we'll just use the simple interest formula and find the amount if the total at the end of 4 years is $16,552.80. So for the first one, we're asked to find the total. So you've got to remember that the formula only finds the interest, and then you have to add on the amount you invest. So using the I equals PRN, you get 2,160. So your total is 2,160 plus the 4,500. It gives you a total of 6,660. For the second one, we know the total at the end of 4 years. So still at that 8%. So this is a harder application because once again, simple interest only finds the interest part, and we need to then add the principal. So for this, we change our formula to be total equals P plus PRN. So principal plus interest, which is PRN. So that 16,552 is equal to P plus P lots of 8%, lots of 4. Work on the back with the multiples. 8% of 4 is 0.32, and that's 0.32p. Collect like terms on the right-hand side. So you get 1.32p, divide by 1.32. So the principal is 12,540. Compound interest. So this is the one where the main focus is on what the compounded amount is in. So the rate and the time are really important here. Okay, so we've got A equals P, 1 plus R to the N. This is on your formula sheet under financial maths. So we've got Cynthia investing 8,000 at 8% for 7 years. And we are going to use this amount for various questions. So the first one is going to be compounded annually. The second one is going to be the amount of interest earned. The third one is compounded monthly. And then the fourth one is a harder application. So first question says compounded annually. Now, a reminder that the A actually finds the final amount. So simple interest finds you interest. The compound interest formula finds you the final amount, the principal plus the interest. So when you put the 8,001 plus 8% to the 7 on your calculator, you get $13,710.59. So the interest there, therefore, is the final amount minus the principal. So $5,710.59. What about compounded monthly? That means that everything needs to be in months. So 8% per annum has to become 8% over 12. 7 years is 7 times 12. So both of those are now in months, so we can use those numbers to actually work out the amount you're going to earn. So we just put those straight into the formula. 8,000, 1 plus 8% over 12 to the power of 84. I would recommend you enter it like that, 1 plus 8% over 12 to the power of 84. And it will give you your amount, $13,979.38. Obviously, that's all the amount with the interest. And if we just wanted the interest, we'd take the 8,000 off. For the final one, Cynthia wants to withdraw the money when it reaches 12,000. So we're going to find to the nearest month when she will be able to do this using both methods. So the first method, which was compounded annually, and the second method, which was compounded monthly. And for these ones, we're going to need to find the value of n, which means the use of log, since we are looking at it being our index or our exponent. So subbing in the values for the first one, you get 12,000 equals 8,001 plus 8% to the n. So dividing by the 8,000, you get 12 over 8 equals 1.08 to the n. You can hopefully see that's a log. 12 over 8 turns out to be 1.5. So I get log base 1.08 to the 1.5 equals n. So n is 5.268. If you want to change that to months, one way to do it is subtract the 5, because that's the years. So you're left with the 0.268 plus the other decimals, times that by 12, and it's 3 and a bit months. So 3 months is what we round to. For the second one, same principle, only this time, of course, we're doing the compounded monthly. So it was 1 plus 8% over 12 to the power of n, remembering that n is in months. So 12 over 8 again is 1.5. 1 plus 8% over 12 is 1.00, and then the infinite amount of sixes. So make sure you use your answer button when you do the log. So you're going to do log of 1.5 over log of answer, so that you make sure you have all the decimals. Otherwise, if you wipe it, just use 1.00 and make sure you put enough sixes in to negate an error. When you do that, you get 61 months. Now, depreciation is also part of this, because compound interest or appreciation means it goes up. Depreciation, the formula changes to 1 minus r to the n. This, unfortunately, is not on your formula sheet. So let's look at one example to put this in place. So we've got a car that's been purchased for $18,500. It appreciates by 10% per annum every year. And we want to know how much it's going to be worth after 8 years. So this is very simple, that you just substitute it straight into the formula, 18,500, 1 minus 10% to the power of 8. That's all you have to enter in on your calculator, and you find out that the amount it depreciates to is $7,963.64. Thank you.